All right, my physical scientists. So here in part 2, we're going to be representing actual chemical reactions that are chemical reactions that happen in the real world with elements from our periodic table. And we're going to be representing them 4 different ways. So we're going to complete our representation using pictures, symbols, and words in actually 2 different ways. Words written like a chemical formula, and then words written in a sentence. So our first chemical reaction is something called electrolysis. You don't need to know the fancy word, but that's what it's called. It's pretty cool. And it's when we run electricity through water to actually break the water apart using electricity into its component parts. So water is a molecule of 2 hydrogens and 1 oxygen, so we call it H2O. So I have 1 water molecule, and I actually need 2 water molecules to make this reaction happen. So I'm going to write in a second water molecule, H2O. And then my reaction happens, we run the electricity through it, and we get these products. There are ending molecules. So notice that the hydrogens are stuck together in H2. We have another set of hydrogens stuck together, H2, and then our oxygens are stuck together. And so we can describe this in words, saying we have a water molecule and another water molecule, and then it creates, what's this one? Well, it's hydrogen. It's just the same as the other one, so I'm going to call that hydrogen gas, because it's the same as the other one, and oxygen gas. And described as a sentence, water molecules react to create hydrogen gas and oxygen gas. Pretty straightforward. Let's try the next one together. So then we have this reaction that is a reaction creating ammonia, which is a dangerous cleaning product. It is a cleaning product you might have in your house, but it's something that can be a little bit caustic. That means it kind of burns the skin, and so it's a little dangerous. So we start out with our pictures of our molecules, and here I have to write in my symbol representation for the whole chemical reaction. But never fear, you can do this. We start out, here we have 2 nitrogen molecules, 2 nitrogen atoms stuck together in a nitrogen molecule. So that's going to be nitrogen. And instead of writing NN, we're going to write N2, so that I can indicate how many there are in a pretty quick and easy way. Then I have 2 hydrogens stuck together, so that's H2. 2 hydrogens stuck together, that's H2. 2 hydrogens stuck together, oh my gosh, this is getting repetitive, H2. And then all of these combine together as a reaction. We mix them together and we get these products, which are 1 nitrogen atom, N, and then notice there's 1, 2, 3 hydrogen atoms stuck onto it. So I'm going to say H3. So it's NH3, telling us that we have 1 nitrogen and 3 hydrogens. And again, we're going to say, oh look, it's a nitrogen and 3 hydrogens. And so I've got NH3. It doesn't actually matter here in physical science whether you write this as NH3 or H3N. We're going to say that those are equivalent, those are the same, they are the same thing. And there are some chemistry rules that dictate how you write them, but we're not going to worry about those here in physical science. So then, in words, in our chemical formula, we can say it's nitrogen gas plus hydrogen gas plus hydrogen gas plus hydrogen gas. It's doing the most. Creates ammonia plus ammonia. And then we can describe this reaction in a sentence by saying nitrogen gas and hydrogen gas react to create ammonia. Awesome. So take a moment and finish these first 2 on your paper if you haven't already. And then we'll move on to this next one. And my paper is kind of blurry, so hopefully yours is not. So here we have the chemical reaction that is the formation of rust from iron and oxygen. So take a moment and write down what we have here. iron, so I would write Fe, and I'll let you continue. And yes, it is kind of annoying, but you can do it. Fe. Notice there's two oxygens, and then we get our products, and this is rust. This is the chemical formula for rust. Notice that it has two irons, Fe2, and 1, 2, 3 oxygens, O3. And notice we have to have two of them. Okay, so then, described as a sentence, iron and oxygen react to form or create iron oxide called rust. Whew. So you might say, oh, this cat's writing this all out was very annoying. And notice I was lazy and I didn't write it out, but hopefully you did on your paper. And it is doing the most. It's kind of annoying. And so scientists like to make it a little easier to write chemical symbols multiple times without having to write it multiple times, without having to write Fe, Fe, Fe. Oh my gosh, so annoying. And so they put a number in front of it instead. They're called coefficients. So here's an example. If you need to make a sandwich, you're going to say 2 pieces of bread. You're not going to say a piece of bread plus a piece of bread. You're going to use the word 2 to make it so you don't have to repeat yourself. So scientists do this as well. And I'll help you out with this starting one, but then I'd like you to finish these two coefficients. So here, we're going to put a coefficient as our same reaction from before, but we're going to make it written in a lazier method, or a more efficient method. More efficient is a fancy way of saying lazier. So here I have iron atoms. How many iron atoms? So here's 1, 2, 3, 4. Notice that these iron atoms aren't stuck together. So I'm not going to write Fe4. That would tell me they're stuck together. They're not. They're separate. So I'm going to say that there's 4 separate iron atoms. And then how many O2s? O2 molecules. Notice these O2s are stuck together. There's 1 set, 2 sets, 3 sets. So I'm going to put a 3 in front, saying that there's 3 sets of O2. Then, how many sets of Fe2O3 are in our products? And I'll let you go ahead and add that in. Awesome. So then, you are going to continue with chemical reaction number 4, which is called photosynthesis. It's got some huge molecule and then many small molecules. So those coefficients are going to be really helpful for you. I'll help you out with this first part, and I'll let you continue the last part. So notice that these are H2s and then O's. So I've got H2O, and I know that that's water. And then how many of them? So here's 1, 2, 3, 4, 5, 6. 6 of them. So I'm going to write the number 6 in front, telling me that there's 6 H2Os. So then you're going to want to do the same thing for our carbon dioxide. So this is carbon dioxide. You've probably seen that before. And we end up with oxygen. So take a moment to complete your chemical reaction. And then continue on with this last chemical reaction, which is called combustion. And again, it has some sort of familiar molecules like water and oxygen, and you're going to write the whole chemical symbol formula yourself, and you can totally do it. So folks, hopefully this was helpful for you in thinking through our chemical reactions and how we can represent them in 4 different ways. We can use pictures, we can use symbols, and we can use words. And we can use the words as a chemical reaction sentence, or in an actual sentence, like an English sentence that has nouns and verbs and stuff. So folks, next week we're going to continue thinking about some combustion reactions and learning a little bit about what happens in those reactions. Good luck, folks, and make sure to finish this last reaction.